Recall the fact that solving linear equations requires the use of inverse operations. To solve literal linear equations, we are going to follow the same procedure, which is using inverse operations. The only difference is that a literal linear equation has some or all of the coefficients as letters rather than numbers. The easiest thing to do here is to look at an example. Consider the literal linear equation ax plus bx equals a squared plus 2ab plus b squared, where a and b are real constants and a plus b is not equal to 0. I'm going to talk about this condition, a plus b is not equal to 0, later on. We are asked to solve this equation for x, so we have to isolate x. Let's start by looking at the left-hand side of the equation. Now, x is a common factor to both terms on the left-hand side of the equation, so we can take it outside the brackets. So we have x bracket a plus b close bracket on the left-hand side. Now, if we look at the right-hand side of the equation, that expression looks familiar. Recall the perfect square formula, which is a plus b all squared equals a squared plus 2ab plus b squared. So we can factorize the right-hand side of the equation, which becomes a plus b all squared. Now, a plus b is a factor on both sides of the equation, so we can divide the equation by a plus b. Recall the condition a plus b is not equal to 0. Because we divide the equation by a plus b, we cannot divide it by 0. For this reason, a plus b is not equal to 0. So the final answer is going to be x equals a plus b.